This tutorial introduces truss rafter modeling in ideCAD Structural. It starts with defining truss geometry, web configurations, and form options. Section types, materials, and alignment settings are customized for chords and diagonals. Trusses are placed, elevated, and duplicated across spans with precise control. Bracing is added between trusses, and purlins and sheeting are applied along the top chords. The video concludes with an internal node detailing the end plate connections for structural support. Now, we previously modeled using portal rafters for the roof. This time, I would like to show you how to model using truss rafters. To do this, I will first load a different version of the project. As you remember, there was a 16-meter span. I want to place a member within this span using the truss command. First, I need to select the node point of the first column. As the mouse approaches, the cursor highlights in a different color. Then, I selected the node point of the last column within this span. As you can see, the truss is now created. I double-clicked on it to access the settings window. Let's start with the General tab. Similar to other commands, it starts with the name of the element, which you can modify if needed. You can define the truss panels either by count or by spacing. I chose spacing-based modeling. The preview at the bottom automatically updates. I want to create panels with 1 meter spacing. On the right, you can see different truss web types. When you select any of the web types, the preview below updates accordingly. All 8 common truss configurations used in the literature are available. You can proceed with the option that best suits your project. I selected the first pattern. When we move to the Form tab, there are 4 options. Only the top chord is arc-shaped. Only the bottom chord is arc-shaped. Both top and bottom chords are linear, or both are arc-shaped. When you select any of these options, the preview automatically updates based on your selection. I prefer to use both chords linearly. Moving to the Height tab, you can see the height of each vertical member and the slope of the roof. You can make adjustments here, and the preview updates based on the entered values. On the Lengths tab, the focus is currently centered. You can also choose left or right alignment, and you will see these changes reflected in the preview window. In the Span Division section below, I will not modify the top chord since it is already divided at the midpoint, at 8 meters. However, I will need to adjust the bottom chord. I will enter 800 centimeters as the first segment length. Next, if you are using an arc-shaped or sloped truss, in order to ensure proper connection geometry at the support regions, you may need to create flat panels near the column connections. In this tab, you can designate these flat panel areas by specifying numbers from C1 to C6. Please note that these parameters represent the count of panels, not their lengths. This is a common source of confusion, so be careful. For clarity, I entered 3, which refers to 3 panels, not a distance. Moving on to the Accessories tab, if you need a console extension from either side of the top chord, you can activate the corresponding checkbox and enter the length in the input field. Additionally, there is an option to add caps to the first and last truss segments. I will skip adding caps since I plan to model truss-to-column flange connections using end plate connections. There's also a groove option. The software does not model the physical gutter or generate shop drawings for it, but you can input the groove offset value here, and manually add the groove in your shop drawings later. On the Elements tab, if you need to remove the last diagonal members for a specific design requirement, you can activate the checkboxes here. There's also a mirror option available. When I go to the Section tab, on the left, you see the available sections. And on the right, you see detailed section assignments for top chord, bottom chord, verticals, and diagonals. The placement angle is also shown on the far right for easier visual reference. There is a load section option. You can access the full section library here. Frequently used built-up sections like L and C profiles have shortcut buttons for convenience. For instance, I clicked on Load L section, selected L70x7 from the library, and confirmed. The software asks for the method and a 10 mm gap for the connection plate. I confirmed the selection, and it was added. I assigned this section to both vertical and diagonal members by selecting the section, highlighted in blue, and clicking on the vertical and diagonal fields. The section assignment updated accordingly. The same applies if you want to use C sections, by clicking Load C section and following the same steps. Below, you can see the Material tab where S235 steel is assigned by default. If you want to use a different material, you need to define it in the project tree and then assign it from this screen. Currently, all components like the top chord, bottom chord, verticals, and diagonals are position-centered. You can also choose top-aligned, gravity-centered, bottom-aligned, or user-defined alignment. When you select user-defined, the delta X and delta Y input fields activate, allowing you to input specific offsets. On the side, you can see the connection type options. Truss connections are modeled automatically. There are 3 alternatives: bolt plus plate, weld plus plate, and weld only. I selected weld plus plate. I will show you how to modify internal truss connections later. I confirmed the settings. Next, I want to adjust the elevation of the truss to properly align it with the top and bottom of the column flanges using end plate connections. I entered -100 mm and reset the offset on the other side to 0, ensuring the bottom chord remains straight. After confirming, you can see the truss is modeled. I selected the truss, went to the vertical left toolbar, and clicked Array. Since I have 5 more 5-meter spans, I quickly created additional trusses. As I mentioned, connections are automatically modeled along with the truss. Trusses have special considerations when it comes to purlins and bracings. To prevent bending moments or unintended forces on the chords, members are only allowed to be connected at the node points of the truss. No elements can be placed between nodes. At the first and last node points, you can either apply an offset or choose to remove these elements to avoid clashes. Let me show this with the multiple elements brace command. I selected Draw Steel Brace Multiple Elements, clicked on the first truss's top chord, then on the second truss's top chord. The software asked for the interval. I entered 2, meaning the second node is skipped, and braces are placed starting from the third node. Reactivating the last command by clicking the mouse scroll wheel, I quickly placed the next set of bracings. Now, I haven't modeled the stability braces yet because I deleted them earlier. To add them back, I used the Draw Single Brace command while holding Control, selecting nodes highlighted in different colors. For purlins, I selected the first truss's top chord on axis 1, then the last truss's top chord in the same alignment. The Purlin command remains the same except for an additional tab named Placement on Truss. Since elements can only be connected at node points on the truss, this new tab is available. Here, you can choose to remove the first and last purlins or apply offsets. I added the offset values, and the software updated the model accordingly. I repeated the same for the other truss chord using the same method. For sheeting, there's no difference in modeling. Since I used the Purlin sheeting command, it follows the same method. Regarding internal truss connections, you can access options like welded, bolted, or hybrid connections and modify them according to your needs. The rest of the connection menu remains identical, so I won't go into every detail. The span division automatically adjusts based on your configuration. Before finalizing, we need to delete the truss connection near the last bay because we will connect the truss directly to the column flange using end plate connections. I deleted it, went to the Connections tab, selected the end plate truss connection, clicked on the column flange, right-click, then clicked on bottom chord and diagonal of the truss, and again right-click, and the connection was created as shown. Thanks for watching. Don't forget to like, subscribe, and explore the knowledge base for more tips. See you in the following video.